In this lesson, we are going to learn how to describe translations for a line using point slope notation and learning how to identify what types of translations are occurring based on what the equation given says. So the first thing that we're going to do is we're going to start with the parent function, the line y equals x. We know the line y equals x has a y-intercept at 0, 0, and then we know that it has a slope of 1. So this parent function looks like this. The domain of y equals x is going to be equal to negative infinity to infinity, and the range is also going to be negative infinity to infinity. And so what we're going to do now is we're going to take a look at what this might, how equations of lines that are translated of this parent function might look like as an equation. So to do this, one thing that we want to make sure we recall is that we have an equation called a way to write linear equations in point slope form that looks like y minus y1 equals m times x minus x1. You could also see this as y equals y1 plus m times x minus x1. So if we look at the first step of this investigation, it says on the same coordinate grid, shift the parent function left 3 and up 5 units. So if we do this in a different color, this would look like if we take that point, our y-intercept, we're going to use that point and shift it. It says left 3 and up 5. So we're going to go 1, 2, 3, 1, 2, 3, 4, 5. And so we have a point at negative 3, comma 5. And it has the same slope, so that's going to look like this. And so now that we have this line, what we'd like to do is write an equation that represents this line. And so what we have there, because we have this new point, negative 3, 5, we could write this in point slope form so that it looks like this. Y minus 5 equals 1 is our slope, and then x minus, or x plus 3, because it'd be minus negative 3. So when you look at this, what you should notice is that these numbers, 3 and 5, appear in this equation. That point ends up being on our graph. And so if you look at that, you'll see it says left 3, and this says plus 3. You'll see that it says up 5, and this says minus 5. And so what you'll notice is that the signs here are different than what might be, or the signs are different than what is happening. And what I mean by that is, if I told you that a graph is moving to the left 3 units, you would probably think that it would say something like x minus 3, because if you go left, those are negative numbers. If I told you that a graph is moving up 5, you might think that it should say y plus 5, because your y value is going up 5 units. You would be adding 5 to that. Now, that is where mapping notation comes in. So mapping notation is a way that allows you to explicitly say how your x and y values are changing based on the transformation. So in this case, what we would say is, we would say take x, y, our original points, and we're going to transform them by adding or subtracting 3 from the x value and adding 5 to the y value. And so what that would allow us to do is, if you look at this initial graph that we had, y equals x, if you start at 0, 0, if you subtract 3 from 0, you get negative 3. If you add 5 to 0, you get 5, which gives you this point, negative 3, 5. It allows you to take one point from your parent graph and move it to the new function. And so what we often will say here is, when you're looking at an equation written like this, is that the equation lies to you 2 times. Okay, it says minus 5, that means you're going up 5. It says plus 3, that means you're going to the left 3. If we take a look at this next problem in step 2, it says shift the parent function right 6 units and down 4 units. So if we do that, we're going to go right 6, down 4. So that would be right 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4. And this is our new graph. And so again, we are able to take this and write an equation for this line in point slope form. Again, this is 6 comma negative 4. So our graph would, or our equation would say y plus 6 equals x minus 4. And again, this equation, when it's written in this manner, is lying to you both times. You have plus 6, you're really going down 6. You have minus 4, you're really going up 4. You could write it like this: y equals x minus 4 minus 6, where you move this 6 over to the other side by subtracting it. And so that then, if you have the equation written so that it is in the form y equals, then it only lies to you once. It is moving 4 right. It is moving, so 4 right. This is telling you it's moving down 6. So again, when it's written like that, it's only lying to you one time. Now your mapping notation, again, is telling you exactly how to move from the xy points on your original function to the xy points on your new function. And so in this case, you would have the xy points from your original are mapping to x plus 4, because you're adding 4, you're moving 4, or I wrote that wrong. 1 second. This should be flipped. That should say minus 6 and plus 4. Because it's moving 6 to the right. So minus 6 and minus 4. So it should say x plus 6 and y minus 4. And then that is your mapping notation for that equation. Again, what do you notice about the equation of the line and mapping notation? The equation lies to you twice. They're the opposite sign, right? So the equation of the line is opposite sign of the mapping notation. So if we look at this first example, it says without graphing, write the equation of the line that has been shifted right 2 units and up 9 units. So if we're shifting something to the right 2 and up 9, what this would look like is y minus 9 equals x minus 2. Again, we're shifting 9 units up and we're shifting 2 units to the right. You could also see this written as y equals x minus 2 plus 9. Again, when it's written in this form, that means that the equation only is lying to you one time, right there. Moving 2 right, up 9. And then to write this in mapping notation, you would have the map of t, or xy is mapping to x plus 2 and y plus 9. So again, what we're looking at here are called, these transformations are called translations. So translations are just transformations that move a graph to the left and right, or up and down. They move it horizontally or vertically or both. And when we write these, a lot of times we'll see them written in this form right here, where the K is telling you how it translated vertically, and the H is telling you how it translated horizontally. So if we look at this example here, it says describe how the graph f of x minus 4 equals 2 times x minus 3 is a translation of the graph of f of x equals 2x. So in this case, you'll see there is a f of x minus 4. We are subtracting 4. So that tells me that because this equation is written in this form, in point slope form, it is lying to us 2 times. So that means it is moving up 4 units. If you look here, that is telling us that it is moving right 3 units. So we have a graph that is moving up 4 units and right 3 units. Again, this could be written as f of x equals 2 times x minus 3 plus 4. So those would do the same thing. In example 3, it says the graph of the line y equals negative 2x minus 1 is translated negative 2 units horizontally and 6 units vertically. So if we look at this, 6 units vertically, we would have, it's positive 6, so we'd have y minus 6, since this equation, when written in point slope form, lies to us both times. And then over here, we'd have negative 2 times, our x is being changed, negative 2 units. So it's moving 2 units to the left. So our x value is changing by moving it 2 units to the left. And again, it'd be x plus 2. And then don't forget, you still have your minus 1 outside that parenthesis. In example 4, it says rewrite y equals f of x as a function that has been translated negative 3 units vertically and 4 horizontally. So that's 3 down, or down 3. This is 4 to the right, because it says positive 4. So our function, in terms of f of x, would be y plus 3, since it is the opposite of what you think, equals x minus 4. Oops, made one small mistake. We don't know what the function f is, so it'd be f of x minus 4. And then you could also write that as y equals f of x minus 4 minus 3. So these two things are the same equation. They represent the same line. If we look at this, it says given the function f of x shown below, graph h of x equals f of x plus 2. Find the value of h of 2. So if we look at this, this is telling us that f of x is moving up 2 units. So what we can do is we can take this graph and regraph it to have h of x. So we'd have up 2, up 2, up 2, up 2. And when you're graphing these, what you look for is you look for the points that are sort of nice points. Those are the end points of the line segments that make up the graph. So you connect your points like so. And the question was, what is h of 2? So the blue graph there is our h of x. So h of 2, you go to x equals 2, go up and go over. You find out that h of 2 is equal to 3. Finally, it says given the graph of f of x below, graph g of x equals f of x minus 2 minus 1, state the value of g of 3. So if you look at this here, again, you'll notice that this is telling you that we are moving right 2 units. This is telling you that you're moving down 1 unit. This is not written in point slope form, so again, this does not lie, this does. So we are going to take the critical points here, 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 there, there, and there, and move them. And so that's going to give us, we're going right 2, down 1, so right 2, down 1, 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 right 2, down 1. So our graph looks something like this. And so the question then asked is, what is g of 3? Well, we found that. So g of 3 would be equal to 2. And those are the notes. So what you can do now is go through and work on the homework and see what questions you have, and then feel free to ask them the next day in class.